Cool. Well, welcome in, guys. I see a lot of new faces. Welcome in. If it's your first time, welcome to ACM. Um, we're the we're one of the CS clubs that help with professional development on campus. So, thanks for coming. Today we're going over a system design workshop. Who here knows what system design is? Does anyone want to share their knowledge of system design? Sure, go ahead.
They used to do like at like a production level scale. So system design is pretty much just setting up the actual things that you're putting together to make the application work. So it's like the collection of servers that run together, load balancers, DNSs, object storage, all that stuff, how it works together to make your application work for millions.
Cool. Thank you. That's pretty head on. Does anyone else have any ideas that they want to share? Okay, cool. He pretty much got most of it. So today we're gonna go, if what he said made no sense to you, don't worry, because we're gonna actually go over all of this stuff and it's gonna make more sense as we go on. So we're gonna go over the overview, go over some key frameworks that you can use to think about it, some basic tools, and then we're gonna do one system design example on a higher level together. Cool. So what's the difference between your apps that you guys build in classes, like your project apps, and apps with millions of users, like the Instagrams and the apps you download on the App Store? So your project, I'm assuming if any of you have vibe coded a project or done an intro to Sweet project or tried your hand at programming, it's pretty simple. You either have your files stored locally on your laptop, or if you have experience with Supabase or databases, you sort of have just one server, one database. You probably don't have many users, maybe like 2 or 3 users, just you and your teammates, and you're doing it for a grade. So if it works on my machine, that's good. But it's simple, but it's not there. It's not what you want to be at if you're making a real app. If you're building your own app, or if you're working at a company with a big app, these websites with millions of users have many servers working together. You have users around the world, thousands of requests per second. People are on your app at all times, on your services. And it needs to be up 24/7. For example, how many of you guys heard about the AWS outage earlier this year? Assuming you guys have heard about it. Yeah. That outage for a couple of hours lost Amazon and other companies $500 million. So you need your services to stay up at all times, spread across multiple databases. And when you have updates coming, you can't have your app crash while you're updating your things. Cool. So what is system design? As Jason touched upon earlier, it's the process of planning how different parts of a system work together to sort of meet the requirements of your product. And you want to take care of certain things like the growth of the product, real world constraints like money, finances, and other failures that you might encounter. So you want to ask questions like, where does the data of my website or for my system, where does the data live? What happens if, say, it's Christmas Day and I run Amazon and I have maybe a 50x increase in traffic? How am I going to handle things like that? You want to think proactively, like what is the first possible thing in your system that might break? And how do we keep things fast and up to date for users across the world? Now, some of you might be freshmen and still just getting into the flow of software engineering and computer science. You might be wondering why it matters. So honestly, it is very helpful in all fields of your career if you're thinking of going into a technical area. So first of all, projects. When you approach your projects, sure, a lot of you have heard the terms AI slop. If you go through an assignment, say for Intro to Sui, and just use Claude to code everything, you're probably not going to know how everything works, and you might have a working product, but you're gonna have to go through a lot of iterations. It won't be organized neatly. But if you take some time to plan out a loose outline of an architecture before you start building, it makes the entire process of building your app and your service so much better. And then internships. When you go to an internship, if you work as a software engineer, on the first day, you're probably going to get thrown into a code base with millions of lines of code. You have no idea what's going on. but sort of having a slight understanding of how things work is almost like thinking like a software engineer. That idea of how things work will help you navigate the workspace and the code space that you're working in very easily. And then interviews, I'd say about 3 to 4 years ago, no one was expected to know a thing about system design. You graduate from college with a computer science degree, and boom, like here's your $100,000 a year job. Like they lay out a red carpet. But it's not the same world anymore. I hate to say it. Companies have started adding more higher level topics like system design. And now big companies have system design interviews. We'll touch upon that in the next slide, but it's more of a it's sort of a necessity now, I'd say, if you want to land those high paying jobs or if you want to build your own startup or things like that. And finally, building something real. If you have a side, let's say you build a project in your free time and it deploys and it's doing well and you have 5 users. And then one day, maybe your TikTok goes viral and you have 5,000 users on your app now. Having an idea of system design and how your architecture of your software is built really helps you manage, growing your company. You won't have to take your entire service down and rebuild it. If you have a sound foundation, you will actually be able to scale your company. Cool. So system design interviews, no matter what field you go into. So look, you can go into machine learning and AI stuff. You can go into front-end design. You can go into lower level design. You can go into back-end like software engineering stuff. Having an understanding of the core principles behind product design and infrastructure design is so valuable in this day and age. And it's what differentiates the people that get the jobs from the people that don't. Okay, so typically after your couple like behavioral interviews, you'll get into the system design rounds. It's about an hour usually with these companies, maybe 2 hours depending on what they want. But here's some sample questions. They might sit you down and ask you, so design Twitter or design Google Calendar. And by that, they mean design the infrastructure and the idea of Twitter. You don't have to go and actually make an app like that, but they want to see how you can think about approaching problems, creating architectures, and they want to see your depth of knowledge in the field of software engineering, not just how well you can do leak code. So this is more of a modern, it gives recruiters a better understanding of how well you understand the topics that they want you to understand, how easily you'll roll off into the industry and be able to be productive. Cool. So let's get into some of the core frameworks. So quick overview. We're going to get into each of these in depth, but this is sort of a way of thinking about designing your systems. This can be in interviews, and this can be in building your own apps. Using these 6 steps, so clarifying the problem, defining the requirements, estimating the scale, design the simplest architecture, identify bottlenecks, improve with purpose. These 6 steps really help you in both your interviews and building things you want to build. We'll get into each of these and we'll help you understand through examples as we go on. So, note for you guys, like bottom line is start simple. You don't need to know everything on day one. If you are a senior software engineer at, say, Apple, probably have to be very well versed with this, but you start simple, you keep in mind those principles, and as you grow, you will change the way you structure your software. And if you keep these principles in mind, it'll help you tremendously. Cool. Step 1, clarify the problems. You have to ask the question. So in your app or your whatever you're building, you want to ask questions. Who are the users? Who is using my application? What exactly are we building? Like, what are the requirements of what are we building? Like, sometimes people start off and say, I want to build a startup. I want to build something, but you don't even have the requirements of what you're building. And then finally, what are the use cases? How are users going to be using our product? So narrow the scope early. You can't start off trying to build $1 billion idea. You want to start small, make sure it works, and then grow as your product grows. Cool. So throughout this workshop, we're going to go through the example of Spotify, and I want you guys to help me understand how Spotify works. So, does anyone want to answer? What are we building? What exactly is Spotify? Yeah.
Spotify's a music player.
Okay, it's a music player. So we'll have people listening to music. That's what Spotify is. So who are the users? General audience. There's another type of user. Um, yes, artists. Artists. So you have two types of users. You have audience and you have artists. So, and finally, what are the use cases? How might someone use this app? So you want to share? Yeah. Yeah. I was thinking more so listen to music, make playlists, find songs. But yeah, phone and computers, how they use it. Cool. So streaming service where users can search for songs, play them, and create playlists. Listeners who stream music and artists who upload it are the users. And the use cases are searching for a song, streaming a song, creating playlists, and browsing and finding music. These are all different use cases. So that's step one, pretty easy, just like asking like basic questions. Step two now, we got to define the requirements. So there's two types of requirements that we define when we're looking at different systems. The first one is functional requirements. This is the easy stuff. These are the features and behaviors that the user interacts with. So what is the user going to do? Are they going to sign up for an account? Are they going to search for something? Are they going to upload something? Are they going to send messages? These are all different things, the different behaviors that you want your app to have that the user will be able to use. Now we have non-functional requirements. This is sort of the back end of this. It's how the system performs. This can be a little bit hard to wrap your head around initially, and if it doesn't make sense, it's okay because like it takes a while to get. But this constraints about how well your product needs to work. It's things like low latency. Say you want the content to be delivered to the user in a fast way. So if it's Netflix, you don't want any buffering on the movies. High availability, it's easy for users to access it. Scalability, you want your app to be able to scale from 10 users to 10,000 users. And data consistency, you don't want two people to access the same song, but it's two different songs. So functional tells you what to build, non-functional tells you how to build it. Cool. So let's go ahead and define the requirements for Spotify. Does anyone have any functional requirements that they might want to share? Play a song, yeah, that's a good one. Yeah, that's it. So like search for songs, artists, and albums, stream a song, create playlists, browse music. This is how the user is using it. And then you have non-functional. Non-functional is low latency audio playback. When a user goes and clicks play on a song, you don't want that song to like buffer for 5 minutes before they can play. You want it to be readily available. You want to be able to support millions of users. You can't have, has anyone ever seen Spotify crash? Like, no, it doesn't happen. You can't have that happen. And you want your playlist to be consistent across devices. So if you add something on your phone, you want it to be like, you want to be able to see it on your laptop. That's concurrency. Cool. Okay, step three. You want to understand the size of the problem you're dealing with. This is not very important in the initial stages of building a system, but if in interview settings and when you're growing your app or whatever you have, you want to consider a couple things. So you want to look at the users. How many users do we have active at once? How many total users do we have? Traffic. How many requests do we have per second? Like I said, Christmas Day or Black Friday, Amazon is going to have much higher traffic, and you want to be able to handle things like that. Read-write ratio. This is an interesting topic to look at. So, is your system going to be read-heavy or write-heavy? If you have a website, let's say Netflix. Netflix is read-heavy. You are not, as a user, you are not uploading anything to your platform. It is fully just the user consuming content. So the data is streaming for the person who is the movies are getting streamed to your laptop, but nothing is going back the other way. So that's a very read heavy option. Does anyone have a write heavy example that they could think of? Yeah. Yeah. Yes. Yes, exactly. You're making posts, you're pushing content out constantly, and that's very right heavy. So you have to think about different things while you're designing both of these architectures. And then finally, data growth. Like, how much storage will you need over time? Spotify is not a very storage cheap option. You have to store millions of songs that people can play whenever they want. So you have to take these things into account. Now, you don't really need to worry about this right now, but it's something that in an interview, if someone is asking you to design a system, you want to talk out loud, you want to talk about these four things, and then the interview will be like, oh, he knows. Okay, so don't overthink the step for your projects, like just getting started. It's easy to get lost in scale that you don't have yet. These are topics, it's like some of those things that you want to give a little bit of thought to, but it's a cross that bridge when you get to it type of moment. So if we look at Spotify, Spotify has 750 million active monthly listeners. So that's their total active monthly listeners. Out of that, let's say they have 50 million people active every day. That's no small number. And with a single database and a single server, you can't really handle that. Now, traffic, they have to be able to handle high levels of traffic. And Spotify, like Netflix, is a very read-heavy service. Most users are streaming music, they're not really uploading it. And you're gonna have millions of songs stored, growing steadily over time, so that's another thing you have to take into account. Cool. Now, this is the most basic and important part of building like any software. You got to start with the basics and don't over-engineer it. This right here is the heart and soul of every software ever, pretty much. That's like stored somewhere. You have a client, which is you, the user, on a phone, on a laptop, on your smart fridge, whatever. You have a database. This is where your data is stored. You guys have heard of the cloud, the imaginary thing where all your data is stored? That's your database. And then you have some sort of API or server communicating between the two. So yeah, these are the three basic building blocks. And when you're designing any sort of thing for any sort of architecture for your own system or in an interview or like if you want to build an app, start with these three and build from there. Cool. So Spotify. You want to click again? The client in this case is the mobile or web app. Like you said, it's just whatever the user uses to interact and play music from. The API or the server handles the requests. When you go on Spotify, you click on a song. This client is making a call to the database via the API. And the database stores the songs, the users, the playlists, and it returns the data back to the client. That's how you're able to stream it. It's the basic workflow. The user opens an app, they request a song, the server fetches it, sends it back, it plays on the user's phone. Cool. Once you have that basic architecture set up, you want to look at what's the first thing to break. You want to think about what's going to break. Is it the server? If you make Spotify with the single client server database, will the server break first? Can the server handle all the requests? Is it the database? Like, can it handle all the reads and writes? Is it the network? Like, if your network can't, if you're trying to send terabytes of data over your network probably can't handle all of this. And finally, can your database hold all that storage? Now, these are things that classes at UF sort of go into a little bit. So when you take intro to databases, you'll go into databases. When you take networks, you'll go into the different details that networks goes into. And like the micro level, but they don't really tie together how everything works and how the entire system works. That's why it's important to be aware of system design and identify what's going to break. So for Spotify, what's going to break? Let's see. If you have one server, can't handle millions of streams. That's not how it works. If you have one database, you can't have 10,000 people simultaneously asking this one database to play a song. audio files, if your audio files are very large, it's hard to get people far away. Like people who are geographically distant, physically, it takes longer for the files to reach them. So let's say you have a server in Florida, but someone is trying to access your music from California. Um, since it's so far away, the way the networks work is it takes multiple hops between different routers, and that takes a really long time. So you want to be able to stream the music to the people who are far away in a very efficient manner. So that also takes some accounting for. That's why in Fortnite and like different games, you have certain lobbies. Like you have a North America lobby, you have an Asia lobby, and you want people to be close by to each other. So there you have a low latency and there isn't buffering. So that's another thing to take into account. And you want to make sure that the edits across devices don't cause conflicts. So now that you identify these bottlenecks, you kind of want to define ways to handle it. And these might not make sense now, but we're going to go into it. So if you have too many requests coming from the client, you add a load balancer. If your reads are slow, you add a cache. If you have a heavy background work, you add a message queue. If your database is overloaded, you add replicas and some redundancy. Now, if you're in your first or second year and you're just getting into it, these are terms that you should have on your radar. You don't need to like go super deep into it right away, but just being aware of what these are will really help you in the future. Cool. Key building blocks. So, a load balancer. What exactly is a load balancer? Does anyone know what a load balancer is? Cool. You want to go? Okay. The load balancer distributes incoming requests across multiple servers, so no single server gets overwhelmed. Means if you have 10,000 people making the same request to the same database, this load balancer is in the middle, calling different servers. And it sort of is an automatic thing that directs flow of traffic. I had a really funny video, but it isn't playing. Have you guys seen that video on like Instagram or TikTok of the guy with the sheep and he's like opening and closing a gate? Yeah, I had that video, but I guess we can't watch the sheep video, but you guys go home and look it up. Um, Scaling the application layer. Another thing you can use, these are just different tools you can use to deal with high traffic. A cache helps you solve for speed. So let's say someone give me their favorite artist. Okay, Pop Smoke. Let's say someone wants to listen to some Pop Smoke and listen to Pop Smoke like all the time, right? If you store their songs on the cache, which means you're storing it locally or on something that has a shorter time to access than say going all the way to the database. You can listen to Pop Smoke whenever you want because your music is stored right here. It's stored close by. So that's cache, which is one of the methods you can use. And just different choices you can make. When you look at database, I'm not going to go too deep into database schema because some of you might not have taken intro to databases, but as you take it, you realize that there's different types of databases. You have tables, which is you have structured data and you have unstructured data. So you can use SQL. Is anyone familiar with SQL? Have you guys worked around with SQL before? A little bit? Yeah. You can make tables and store data on users, playlists, follows, artists. You can have a lot of tables. So if you have an artist table, you can have a table with an artist and all their songs, right? And then NoSQL. So if you guys have heard of things like Supabase, Firebase, these are all flexible, unstructured data. And you can store things like listening history recommendations using NoSQL. And finally, things like songs. You can't store songs in tables. That's where the idea of blob storage comes in. So how this works is you have a separate database somewhere else with a lot more memory that stores the data for songs, the MP3 files, the MP4 files. And these files don't belong in a SQL database. You just have sort of like a reference, if you guys know what that is, a reference to where in memory this is stored, and you put all your audio files, your images, your videos in this massive blob storage somewhere else. And so whenever you're designing a system, you want to pick the right tool for the type of data you're storing. So you need to, if you're storing big data like videos, images, blob storage. If you have just like text, numbers, that can go in your databases. Cool. Now, here's some other tools you can use. This is just like, these are all tools you put in your toolkit that whenever you come across a problem, you're like, oh, replication. That makes sense. So, replication is the idea of having multiple versions of your database backed up to different places. So, you copy your database to spread reads and you provide backup if an instance goes down. So, let's say you have one database with your users, like very important data. And for some reason, the intern goes in and wipes everything, like it's all gone. And now your company's worthless. But if you had actually taken care of backing up your data somewhere else, you wouldn't have been so screwed. But if you didn't, then like, I'm sorry, your company's worthless now. So replication is very useful to have. Um, the other thing you want to have is sharding, which it's not sharding. You split your database into pieces, so no single piece of your database holds all the data. It's like instead of having one big fat database that holds 100% of your data, you kind of like index it. So maybe you have four, and you have each database hold different values. So that's another way of splitting your data up, making sure you don't have one massive thing. It's like if you had $1 billion, you wouldn't put $1 billion in your room. You'd like divide it up and like put it in different places. Now, messaging queues. This is kind of interesting. This is a method of handling heavy tasks in the background. So, for example, Instagram in like the early 2010s, um, in order to make it seem like they were a very fast service, what they did was whenever people uploaded pictures to post to Instagram, they would already start posting the picture in the background, like loading the image onto their servers in the background while these people are adding their captions. So what that did was as soon as people added their image and their caption, press post, in their mind, it seemed like it was instantly posting to the internet. And that's one of the things that got Instagram so much clout. They're like, oh my God, you're posting videos and pictures really fast. But actually, they were like using queues to like start heavy background tasks ahead of time. And this is just one of the ways you can think about solving these problems to sort of make your systems more efficient. Cool. And finally, CDNs. These are content delivery networks. Let's say you find your favorite Pop Smoke song. I can't really remember Pop Smoke song off the top of my head, but do you have a song? Dior. Dior, yeah. Okay. Yeah, damn. Let's say you find Dior and you want to stream it back. The database CDNs help you find the closest the closest server that can serve you that piece of data. So it's not coming all the way from China. Like it's going to come from somewhere close by, and you have less like buffering, and like you can listen to Dior really quick. Like you don't have to wait at all. Cool. And when you're designing these, you always have to think about trade-offs. If your app has 10 users, you do not need to have a load balancing server and be paying like $100 a month for that. Like that is not necessary. So like more servers equals better performance, but it also costs more. So like in the real world, when you're dealing with real money, you can't just blow it all on servers. Um, Caching, which is faster reads like we talked about, to store all his Pop Smoke songs so you can listen to them faster. You have the risk of stale data. So if in some cases, if this data is getting updated instantaneously or very often, and your cache is storing old data, you can have some stale data. Replication, which is like if you have multiple databases, you want to make sure they're all up to date. And then sharding is it's harder to query across shards, so you want to make sure that like everything is organized well. And there's no perfect system. Everyone has their own way of doing things. There's different ways of having the same output, and only the right trade-offs. Find the right trade-offs that work for your use case. Now, I'm going to go through a simple demonstration of Spotify, and we're going to draw out their, like, one of their system design, like, diagrams. And I'm not going to go too in depth, but I just want to show you guys how in an interview setting, you would think through and kind of set up like a diagram. So let me go ahead, go to the right monitor. Cool. You guys see that? Okay. So what are the three basic building blocks that we talked about? Okay, client, that's their phone, right? So we're going to draw their phone. This is someone's iPhone with Spotify, right? This is a client, and we're going to call this the client. Cool. What else do we have? We have two more things. Does anyone want to share? Yeah, API or the servers. So we're going to draw the servers right here. Okay, cool. This is your server. And then there's one more thing. So you want to share what the other thing is? Database, yes. And you have your database. Cool. Now, in a simple world, your client talks to your server, which talks to your database, gets your data, sends it back to your server, and comes back to the client, right? It's not the world we live in. That's your intro to Suite project. That's not Spotify. So we're going to get rid of all of that. And we're going to add different things. So first off, we're going to have multiple servers because you can't serve 10,000 people simultaneously with one server. So we're going to go ahead and draw, say, 3 more servers that handle this data. And what do we call the thing? What do we call the service in between the client and the server that diverts traffic to load balancer? Yes. So we're going to draw this load balancer right in the middle. We'll call it LB, and it'll go to each server, and that will decide what server gets called. Now, this is a very simplified view. There's a lot more that goes into it. There's a lot more detail you can get into, but this is a great introduction, and it shows you what we have, like how the basics of designing a system. Now, what do we call the area that we store all his Pop Smoke songs on that's on the device or easier to access? Yes. So we have our cache, which he can access, which a client can access very easily for their frequently played songs. Now from there, the server, we're going to make multiple databases because we're not just a single database. We're going to have multiple databases, and each database will store different kinds of data. So let's say, sure, we'll say users, songs, and artists, right? So we'll give each of these just 50 GB because text is not that hard to store, 50 gigs and 50 gigs. And finally, what do we store our songs in? It's not stored in a database, it's stored somewhere else. Yes. So we have our separate storage right here that we'll make it rounder because it's a blob with, say, 500 terabytes of storage. So we'll say 500 terabytes because songs take a lot of time to listen to. So we'll take our server. The servers will communicate. I'm just going to draw one line that'll communicate with all of these databases. And then it'll have the ability to go down into the blob storage. And from the blob storage, once we have the song picked out or the whatever we're sending back, we are going to send that straight back to a CDN, which will distribute your your data and find the fastest way back to the client. So that completes the loop. You go from the client to the load balancer. Let's say you make a query for a song. You start at the client, check the cache. Is the song in there? If the song's in there, take it from the cache, play the song. Go back. If not, we're going to go to the load balancer. The load balancer will find the server with the least amount of traffic and send your call to that server. So based on the server it goes to, then it'll call the database. So it'll look at the song database, and the song database will have a reference to where the song is stored in the blob storage. So now from the song database, we're going to go into the blob storage, get the song data, the MP3 file, and stream that straight back to the client, the app, in the fastest way possible. And that is how you design a system. So that's pretty much what it takes to build a system. Does anyone have any questions on the architecture? This is like a pretty simplified view. If you have a system design interview, there's a lot more that you can get into. You would want to get into database design, how the database is structured, and just like the different data structures that you're going to use. And there's a lot more you can get into, but this is the overview of what it looks like. So going back. Cool. Beginner tips. Start simple. You don't have to have the entire complicated diagram. Start with the client server database. That's all it takes. You can build anything with a client server and database. A single server and database is a valid starting point. You want to understand what you're building before you're building it. Sometimes I've done this a lot. When I start a project, I'll just like start coding and like be like, okay, I'm going to build something. You don't know what you're building. But now you know that like having an outline, having a structure of what you're going to build, even if you don't make it yourself, if you have like Claude or ChatGPT help you build it, that's a good starting point. And then you want to define what you're building and who it's for before you touch the architecture. Like have your purpose set out and set in stone. Then add complexity with reason, which is like as you go, you find out, oh, I need to have this feature. So you add that feature. So start simple and get bigger. Like start adding features as and when you deem necessary. So everything should have a reason. Everything should solve a specific problem. Don't design for millions of users on day one. Like it's easy to get caught up and like buy all these servers when you don't really need it as of yet. And build for what you need now and evolve as you grow. Pretty self-explanatory. Ask what breaks. As you're growing, you want to be proactive and hopefully find your weak points in your applications and your systems before it actually breaks and you have catastrophic like things happen to you. And pretty much if you keep all this in mind, you're set. Now, system design interview tips. Let's say you are in a final round interview with Google and they ask you to design Spotify. You're like, oh my God, I don't know how to approach this. Please ask questions first. Those first 3 steps we took, where we defined the use cases, the requirements, and how much traffic we have, and the different criteria and the scale, you always want to clarify that with your interviewer to make sure they're on the same page as you. They're not going to be quiet. Well, sometimes they might be, but usually they'll be responsive. They'll help you understand what you're building for. After that, think out loud. Talk through your thought process and don't just give them the answer. So like I did, start simple and get more complicated from there. Don't jump to a complex architecture immediately and be ready to explain why you chose certain approaches over another. So one of the things that we didn't touch on here is be like slightly familiar with the different storage services, like use like AWS or like GCP, Google Cloud. And be like slightly familiar so you're able to talk about your different choices in certain approaches. And it's not a test, like you are having an interactive session with your interviewer. So talk through that. Finally, a couple resources. So I'll post these slides on the workshops tab. And if you want to learn more about system design, this is probably the best resource you can use. It's called System Design in a Hurry. It's like 5 pages. I realized I had a system design interview like 2 days before I actually took it, and I read through it and I like managed to scrape through. I got the offer. It's like that is very good to read. Free Code Camp has like a YouTube video, like an hour long, which goes slightly more in depth. And these two textbooks, if you're a textbook person, if you like reading textbooks, I don't love reading textbooks, but like if you do, these are very in depth. And like I showed in that diagram, like if you're going into a certain field, you will have field specific um, design practices. Like machine learning uses a different process than, say, front end development. So you want to be specific and know what you're preparing for. And yeah, any questions?
Yeah, so if I want to practice my system design skills, like, is there like any sorts of resources where I can like practice like problems?
Yeah. So system design in a hurry has a lot of practice problems where they'll give you these examples, and it's almost like leet code, where it's like easy, medium, and hard, and you can go in and sort of practice through that, and it's a great resource.
So is
And
there like a lead code or system design?
I think it's system design in a hurry. I don't know if there's yeah, hello interview.
Work, algebra, and you go in, and you like create the diagrams, and then you like submit it, then they have their AI that looks at it, it tells you what you missed, and whether you overkilled it, and then you can set the difficulty from beginner to mid-level to senior, and so like it will have specific, um, so if you're a senior level person doing system design, they might grill you on, okay, like, how can this be faster? Or are we wasting compute everywhere? But if you're a beginner, they might just want something basic. So this is like the number one resource for system design for sure.
Yeah, and there's also a lot of YouTube videos where like senior level like architects go into system design. So if you look at the hierarchy of engineers, the junior level engineers are like not really working on this level, but as you like move up and as AI starts doing more of the like coding tasks, you're going to be more concerned with this. So I think it's a very relevant skill to have and to grow, and it's one of those things that can set you apart. Any other questions? Okay, well, our upcoming events, we have a hardware workshop. So if you're interested in learning about hardware, on March 4th, we're going to have a workshop with We See Women in Computer Engineering, Electrical and Computer Engineering. And we have an upcoming Datadog partnered event where we're going to have a recruiter coming in, and we'll be posting more information about that. But you get to meet face to face with recruiters, people that work there, get your name heard, get your resume seen. So come out to that. And as always, we have Fishbowl Fridays. It's Fridays of Malachowski, 1 to 3 p.m. It's in our ACM room. So you walk in on the upper level, walk straight back to the right, and we're just gonna be hanging out. We have food, just like chill. Like it's very chill. But that's about it. Thanks for coming, guys. Okay. And meeting. Yeah, yeah.